Perfect. Yeah, so that doesn't work. Why am I keep on trying to press it? Right, so I just want to kind of take a minute to do an example showing where we know the truth. We know we have electron density profiles from an inquiry and scatter radar when we have a complex ionosphere and we have an ionosphere co-located with it. So why don't we try to look at some of the electron density profiles and the ionograms and try to relate some of the features to each other. So this particular event is a really, really cool, again, run at Tromsø, where we have pretty much all of the different types of things that can disturb the ionosphere. We've got, auroral precipitation and a lot of high energy precipitation as well, occurring in the morning. We have these tidal convergence operating on the E region and more F region, resulting in a detached lower E region, as well as, if we had metallic ions, we would have sporadic E here. You can even trace this tide out into the next day, where you can see, a thin layer of non-metallic ions, well, actually, probably these are metallic ions, but a very, very low density of metallic ions available, so we don't get a full sporadic E layer. And then, of course, in the F region, we have TIDs. So we have these slanted wave structures in the F region that move their way throughout the day. So we'll start off right at 1 UT. So 1 UT, you look at the ionogram and you see this. And the only reason why I'm showing this is probably very similar to what people saw last week in Europe in their ionograms. What this is auroral precipitation. This is a thick E region profile. If we go back to the previous ionogram, this is at around 1 UT, so it's around here. Okay, so we have a very thick E region that is blanketing the F region, and associated with that thick E region is also a lot of enhancements in the upper D region, which means that's coming with a lot of attenuation as well. In this particular case, the maximum frequency, critical frequency of the auroral reflections are 4.6 megahertz, or 11.4 in terms of this weird log scale that I used here, which would put it roughly at this color here, which pretty much aligns with what we're seeing in the ISR data. In this case, if you're using descriptive letters, you'll want to classify this one as K, saying that there is precipitation contaminating the ionogram. We go to 4 UT. 4 UT, we are now, somewhere around here, right? So we have the precipitation has started to wane off. I will mention that this mode is only going up to 195 kilometers or so, which means that we don't see the F2 region. Okay, so this is only going to be giving us information about effectively the region below FOF1, or roughly in the F1 layer, if there is one. And so we see reduced particle precipitation intensity, and we're now starting to see our F region. And when we see our F region around 4 o'clock, unfortunately, we don't have anything visible worth looking at in that case. I will say one thing. In this case, we have, or I guess how auroral sporadic E or auroral E region traces differ from conventional E region traces in scaling is that we do not have a way of estimating what the valley between the E region and F region is. If you look here, we do not know the relative thickness of the particle precipitation. We only know the bottom of that and that there is an F region above. And being able to infer that valley, like even in conventional ionograms, when we have an E region trace, we don't know what the valley is. We have models or we have some way of spoofing what that valley is. And because the valley is typically relatively, not particularly large, even if we get an error in that, the error in the inverted profile heights are going to be on the order of maybe a couple kilometers. But if you trace this trace here and then do a normal F region trace on here and try to invert that out. You can either really heavily or really heavily overestimate or underestimate the effects of ionization between these two layers when doing the inversion, and that can be it just means that there's a lot of uncertainty, and I would generally not record the traces in this case, or at least not try to invert them with a conventional inversion software. There are other approaches that try to use the maximum critical frequency of the aurora to figure out what the precipitation spectrum is, and then use that information to try with a model to create roughly the vertical structure that accounts for the E region, and then invert out the F region. That is not something that happens in SAO Explorer, and so generally, again, avoid letting SAO Explorer or an HPC invert these ionograms if you can. Right, so we can move on to about 6UT. 6UT. Now we do have a little bit of F region up here that we can actually start to discern. We're almost completely out of the sporadic E. We do have quite a bit of a valley between the auroral precipitation. We do have a bit of a valley between the auroral precipitation and the F region, and so we're seeing quite a bit weaker auroral precipitation E region trace here, with a cusp, and then a corresponding F region trace. Again, this is not scaled by me. This trace is scalable. It's scalable in that the auroral precipitation is at least at low enough densities that the bias that you would get from an HPC's inversion shouldn't be a significant bias compared to its normal errors inversion. So again, our FOEA, or the frequency of auroral precipitation, critical frequency of the auroral E layer, is about 1.6. We can go back around here. 1.6 corresponds to about 10.5. 10.5 is somewhere in this orange. Yep, that aligns pretty well with what we're getting out of the ISR. You can go to 12 UT. If you go to 12, we've got we're in the middle of everything, right? So we have this descending, splitting E region. We have this extended F1 layer here, and we have all of these TIDs starting to operate in the F region. And so we can see we have a small E region trace here, and we have this really long, extended cusp. This is the F1 trace here. And it's very extended because the gradient in electron density in this region is very, very shallow. The ionosphere is practically flat. And so we're getting a lot of group delay as the signal is propagating very close to the plasma frequency for a long period of time. And so that's creating that exaggerated cusp. And then this trace is again is pretty easily scalable. Artiste, it's a 4.5, so it does a little bit of the edgel stuff. But generally, I would trace here, follow this up, and then follow the inner edge like we did before for spread F. You can also start to see some other echoes coming in here. This isn't a Z mode. This is likely from those TIDs in the F region. We can go to 15 UT now. So 15 UT is somewhere around here. We've just hit sunset. This is in winter, so it's ionospheric sunset, we'll call it. And we've got the TIDs are considerably more intense with respect to the background. And they're descending into the lower F region as well. And again, you're starting to see a lot of spread and also kind of two distinct populations of echoes, some coming quite a bit off vertical due to the slants, because the TIDs don't have an infinite vertical wavelength. They have a slight slanted structure, and so you're also getting crest and null scaling or reflections. So in this case, you can look at the edges of these two traces and find, somewhere somewhere between 0.5 megahertz and 6 megahertz, and that roughly translates to about 1 color scale difference between the crests and also the TID, and that pretty much corresponds exactly to what we're seeing in the ISR as well. In this case, we would classify FF as 0.9, and again, we would scale the bottom and then the trailing edge of the trace. Everything here it's high latitudes, but it's still not overly complex. We just have to be aware of when we have auroral precipitation and mitigate against. This is going to be a long set of examples, but I think at this point it's probably better for us to just move into doing the examples with you guys and guiding you through stuff. So if you want some, examples of me scaling stuff, there you go. There's all the things there's a bunch of scaling I did this morning. Just to finish off, generally you want to make very effective use of that X mode reflection. It's a saving grace in a lot of circumstances. You want to be aware of your interference or restricted bands, and be aware of if you have early truncation of the F2 trace, making use of the X mode to fill that in if you can. Multi-hop can both be a problem and a solution in a lot of different ways, depending on the context. Solution, particularly with spread F. Having a time history of critical frequencies of the underlying layers can be incredibly useful, particularly for defining G condition and for mitigating TID's effects on FOF1 and FOE for that matter. And one thing I'll just kind of implore in general, if you do not know how to scale something, if you do not have confidence in that scaling, don't scale it. It's better to not scale at all than to scale and have it be poor. Like Yvonne was saying, when we submit these to Giro or use them in paper format, we're putting the stamp of approval that this has been manually scaled, and that kind of holds a certain weight to it. And so we want to avoid a situation where you're being over confident necessarily in your scalings that otherwise really probably shouldn't be done.
You have to remove all layers.
Yeah.
And submit that empty.
Yep.
It will be okay. It's a statement.
Yeah, and it's
a complicated ionogram.
Yeah. There are ionograms that just can't be interpreted. It happens a lot.
for which there actually exists a specific descriptive letter.
Yeah.
It's the letter N for not scalable.
Yeah. Thanks.
Yeah. So before we go to the other examples, Ivan first has another thing to show, and then we will go into the second set of practical examples for you.
What I would like to do, what I would like you to do, is to contact me while there's a couple of hours left. Is it a couple of hours? Something like 1 hour left. Talk to me. I will be sitting on the first row. I will arrange accounts for you as a scalers, right? So that you will be able to submit your results of your work to DID-base when you feel like you are ready to submit your results. For now, you can connect to DID-base in Lowell and just try to see if you can find particular ionograms that, for example, David just showed. You can look it up. We didn't prepare them necessarily, right? They are not in the training set. They are not. But you can see if you can get them from Lowell, Massachusetts. In order to do that, let me see if I can go back to our Explorer here. Do we see it? I will need that magic button to. Okay.
Is this the magic button?
All right.
You just say duplicate.
No, he's the expert.
Okay.
Okay. Thank you. Thank you both. Yeah. Okay, so what you want to do, okay. So you go to database connect. Sorry, cancel. You go to file database connection. Okay, on the top level, you may say something like Lowell for the name, right? Because there are some mirror sites on the planet. There is one in Czech Republic, right? There's one in South Africa, one in China. So, but this one is in America. You keep this. For right now, you say AT-RASC. I'm pushing all wrong buttons because it's a different AT-RASC 24. Is that clear? Okay. And the password is student, all lowercase. Then in the list of databases, pick up a vacant spot and hit save in list. And then see if you can connect. Okay, I am connected. Are you? Anyone successful? Let me do it again.
If it says at the top of the screen, no, you don't mind. You are connected to the podcast. And you now have access to all.
Okay. So that will keep you going for the rest of the day. Okay. That account will be kind of quietly removed, maybe in a few days. But please approach me in some organized fashion. If you want a personal account for ionogram scalar, I can do that too. All right. What I will need from you is basically passwords. I will need 2 passwords from you. One for the organizational account. Suppose you're in the Met Office of UK, so you would like one account for the whole office. You will be responsible for it. And then you will get a personal account as an ionogram scalar with your name, last name. So every work that you will submit to database will be preserved under your name.
You don't need a scalar account to be able to download and scale things.
Yeah.
Correct.
It's encouraged, but
We will anyway after this day, like one of the coming days, we will send an email to everyone with also with the slides of all the presentations and so on. And we will put there also the email address that you can contact Ivan out to ask for this if you don't get to do it today, to get your personal account or institutional account. But at least for now, if you want to play around with it, you can
Well, it seems to be connecting, and then if you are connected, you will see that lightning symbol, which is a query to DIDbase. You hit on that, it will say which station you want out of 120. If you don't know which times, because you don't want to hit that no data, there are a couple of buttons like calendar tree and current station, so you can see data availability charts. And then it's for a occasional work from overseas, it's very convenient. If you would like to find some remarkable examples that David just showed, yeah, that would be quite straightforward. That's all I have. And
the
that's-
vertical toggle can also be helpful. Right now there are a lot of oblique ionograms, so maybe use vertical. Sorry.
Yeah, one last comment. There is a query form at the bottom for targeted searches. For example, you can say S dot confidence less than 50. I didn't get the less sign, right? It's in the wrong, it's in the somewhere else, yeah. No, okay, there it is. No,
That's larger than.
larger than, yeah, less than 50. Suppose you would like to select the least confident artist scalings so that you can fix those quickly, which are most important. Outrageous mistakes, yeah, that will be one way of subsetting within the interval of your search all data to the low confidence data to fix it. And one last point about the button that you need to enable as a scaler, because you log in as a scaler. Let me log in myself. There's a shift. Sorry, I keep, yeah.
Now you have all caps.
It's okay. So I'm pushing login, and it checks my credit card. The credit card is good. Just kidding, just kidding. Then in the scaler, you say option auto submit. That's the one that I said you should use. That case, you will not lose more than a single editing record that you are preparing. And of course, right now, because there are 15 people connected to the same database at the same time, it's going to be a little bit slow, but from the comfort of your kitchen, you can scale ionograms when you don't have much more to do. Questions? No questions, no answers. Let's go back to our favorite ionogram scaling.
Yeah. So exactly because the database gets slow if too many people try to connect to it, we recommend that you play with this later on, like the coming days. And that now we will continue with scaling the examples for which we provided you the files already available for them. So as our explorer can either this way get data from the kilo database, or you can open locally files. And so we will now do that. I don't know if most people or most groups are able to scale at least one way of like easy ionograms today. Then you can look at the second sets of data. Do I need to put up the link again where you can find them? You can look at the second set of data to realize that there are still many, many things that you have not learned yet today, despite being here already for a whole day. So this is the link, ionosphere.meteor.be/ursi.html. If you feel confident that you've understood how it works for the easy sets, then you can pick at random one of the sets in this set here. They are very different. So I did some database queries to find very confusing ionograms. So some of them are like earlier this day are hourly for an entire day. In some cases it's like a series of ionograms to really show you how a certain strange feature appears and disappears and so on. So yeah, you can just pick one at random, and if you are lucky, it might still be somewhat doable, and if you are very lucky, it might be something very interesting. So yeah, if everyone feels confident in being able to scale the easy ones, then you can look at the hard ones now. We still have like an hour or so to work on this, and same as before, if you have a problem or you are ready with a set, you can ask one of us to come look at it. So yeah, that's it. Go ahead. Most of the sets
most of the collections that I put in this second set have one particular issue, like there are sets with spread F or sporadic layers or something else. There are a few only that really are like what David was showing here at the very end, where you have many different things going on at the same time. There aren't that many of this difficulty in this set yet, so you have a chance.
Because if you find something like that, you know that this is something wrong. Very interesting. From Jeju Island, there was one second time. Yeah, I'll just say because it's one of the first ones that you will see a lot of life to this point. Set from Jeju Island is the most. And Jeju Island is great.
Yeah. Yeah. Well, then there are diagrams in the ones that are we don't have ray tracing. What I want to do is do ray tracing for all of the just the ionograms you get from RASC versus the other. See what I want. So yeah, the resolution is yeah. No, I was just thinking
Yeah, because the same one's yeah, we were talking about this.
sorry. It's really fun if you have to entertain yourself all day. Yes. This is the conference.
There are actually more than one category. This is even so that sometimes you don't see anything about it. But then this was the image that was strong there, but then also that certainly is complete reflection, but it might not be from this it's probably one of the Japanese sounds that is at quite some distance from it. But yes, we have the same idea, but really it's halfway between this sound and
the views are there. They're going to see this thing that also kind of terrifying. Yeah.
but they do this. The Japanese
Okay, sorry. Heights are just stress and driving. They're aggressive.
And it is also at exactly twice the height, which clearly indicates that this is a second reflection from that. Now, the question is it sporadic layer or is it a thick E layer? Because you can see that everything just up does have this delay, which, yes, so this is probably similar to the example that David showed, that you actually have the E layer by time is also splitting two. But in such cases, the second one is usually marked as being a type of sporadic. Yeah, I mean, yes, but so that kind of split is considered a form of sporadic. The sporadic is the one that kind of feeds. So you mark it in the exactly you mark it. Yes, that's how you mark it. But you mark it because if you see the guide, you mark that in time. So you put it in a on the place where there is actually nothing, because you put that frequency and the height, even if there is no point exactly. So you might mark that height, that frequency. So usually that is another thing where the book has a whole chart dedicated is to identify the different types. Because also there is this typical way of the other guys crashed together, but then another example that we is from the particle classification. This is another type of particles. And then this is then another type of type of force producing the split event. So there is another item in it, and it's actually if you look at this very close you can see that there is one field there that is called type yes. There it says type yes. There is nothing there, but so that is the field that can then also be used to talk about how to do that to identify different types of because if you just mark sporadic layer, anything beside the normal layer, anything that is in this high range is called sporadic layer, but that covers actually the physical things. So then, if you know, okay, this is particle precipitation, so thick layer is a thin layer, they have those types of effect. Well, so the E layer is always applied 100 to well, I
Well, consider it
yes, actually, it's a little bit more than but it's called the software will actually, if a point is exactly twice the outside, the same thing is not anymore. Now that does not work perfectly because sometimes it's like 1 pixel higher or lower, just by around, but it works quite well if you move in and good reflections. Sometimes you want a good reflection because sometimes it's useful to give some information. Yes.
Yeah.
And you can never see everything. If you see everything,
Okay. Well, because I've heard the name before. That's good time. Yeah. Okay. It's human and on the same thing. I'm on the same coast as you guys are. It's just as humid and hot as possible. No, I know. It's not Thailand's fault.
so what I would think that within this group, you actually have two completely very different, but very different, right? Because this much. So that is what I think is good. Now you can do some things like so left and see like that's not really all they want. Well, because I think you can also see that both of them both of them. So yeah, but this is really not the second convention. Yes, so you don't always
Yeah, we're there. Well, we went downtown like one day. It was great. It's like we're getting paid for that. Feel bad.
you can also this is another but it is in we'll see if there be yeah. So at some point you will just start scaling down steps. Okay. Yes. So the more you scale the one, if there is one that is key or one else than the other one, then you scale that. Well, if one is clearly stronger than the other, you take the strong. In this case, yes. But if they are really clean, I would say yeah, more or less the same level of scale that yeah, that's the best
What do you guys do?
Well, what's that next thing?
Thank you.
That's fine. That's possible. We can talk about efficiency for a second. Yeah, so it's real. That's again could be a primary F region or some sort of descending layer. Just an intermediate. Well, you just try to build a multi, but it's not.
Yeah,
it's
but
a line. I know.
most is not always
I know.
do perfect.
But yeah, I wouldn't be worried about it. It's not what's.
It's still is good to have.
It's not part of the main trades. It's not.
That I see quite often. So that you have a sporadic here, and then the first hop is not only here, but the second hop is where it's that happens quite often. I don't know why.
Now, this is kind of, it could be, they had one time, directly to
But then we right on the edge, so it should not have been because it's kind of low. At least if you have two hop, at least the first hop is not otherwise again it's still one. Yeah, yeah.
So here, like it's behind. So what would you say would be the is that
It depends on the time of day where you are. Generally, it doesn't typically go below 200 kilometers. If it does, then you go check. But it can go as high as, like if you're in equatorial, that's 550 kilometers.
yes, 300.
Yeah. 300 is standard at night. Yeah, really standard.
Okay, so it's also because this is times of day time.
So, well, the standard variation of the is high at night. So, if it's below 200, just double check that we haven't accidentally scaled. But I would like even in that case, the scaling is still correct. Paper or plus is correct. It's just putting the yeah as well.
This profile change. I think I've marked this like this.
It doesn't change the profile, but you would mark just right where top. If you break it, yeah, just show you slide there. Yeah, that's right. No, don't put the mic right now. I was just saying that that's an issue. Yeah, maybe set to the right. So that would be very similar to the one that I showed here. So that's but this is normally Even though it's described like so it's a compressed layer, but it's not a thin metal kind. It might eventually form a spread of these, or yeah, I still mark it as spread. But if we had the option, I would change it to because it is enough. So the inversion, I think we want that. That's all. So it's just we have this kind of conflict.
Somewhere else.
In this case, it's a little bit of a wiggle in there, but it's not that sporadic. Yeah, okay, so we should show these here as well. That's great. You see how this sorry. And it's like personally, I do it because it's like I can watch it. Because it means I'm doing work, right? An episode of the TV show. That's what else am I out there? There was one. I also just listening to a post. I put on like the Office show that I've watched a lot. So it's like so you're the sound. Okay. This is a case. That is what was that's similar to what a lot of mine. So yes.
Which there are specific letters indicate you can indicate that the thickness is higher. Now in this case, like if you just tiny one, so one thing that you can show maybe at some point. So I think that this part foundation I think that's also really like it's only going so I think that you might still be reasonably confident in the features. The height, yeah, the bottom is clearly not yet going on horizontal, so the height will look like it is going
It's just to say that yeah, that's what we're going to put it in some details.
So you have, if you click on the loop, then it might see. No, that's just your line. The pose, you can clearly see the so this is exactly twice with the that was not looking at
That's the Linux issue, right?
yes. I can
Well, I don't use Linux.
Yeah, because I think
I'll fix this one out. Sure. That's well. I heard the weapon profiles. You can compare so as that measurement. That's right. No.
I suspect that the way the one version does have some challenges. It's not really it's because it's so if you version it's good to know, so you can try to find this. Have a way of validating why it's
The software from the
yeah, quite a bit widening with the TID. This is Jason. Again, the X1 is the same. Well, they're not that far. But it's the different direction in which they're looking. Right? So so if you have a TLP, you want to take one direction or the other. You see if one, you can see the wind. Yes. Absolutely. So you have to be aware of that. You're just kind of looking for it. Oh, it's just a as soon as you do an inversion, it's only once you do an inversion. If, like, it might say that there's no predicted F1, that's the thing that there is. So I'll go to the previous assignment. Just see how it's kind of sliding down. Also, look at your expo. It's kind of turning down to a very similar frequency that you're getting. If it was an actual trace that should be separated by the same distance between. So you should see a very, you should actually almost see the green trace run into the train and then train down. You're not seeing that. It's suggestive that it's slight gradients. It's ordinary mode and it's turning mode, opposite directions. So if there's a TID, sometimes Often I do have this effect just because this separation, the actual physical separation, so you can use that capital for which one doesn't. If there's a difference between two, you might have TI for one.
But ultimately, yeah, so that is the issue that is and then if you fix it, you wouldn't go for that. It's the idea. Well, it's because it's just saying.
And then scale the way that you think that. Well, what you just said. So the I mean, like,
I mean, you want to check very careful.
So I would actually back this off by here, following the leading edge. What I'm trying to say those curvatures are
I think that
you're correct. That's the right one. Absolutely correct. Specifically, again, you can just check your X values and say whether no actually is there.
yeah.
Okay.
But yeah, so ultimately it's already usually
Yeah. Well, so like, if your choice has to do that, it's probably not.
yeah, because these are also
It's really
not easy to go first. That's more if you were if you have
especially with an inverted touchpad like that.
most of them
Yeah. It's not. Yeah.
I actually have in my slide that I have put like a specific and like specifically going for the maybe it's all this. So the problem is that if you don't finish a from it tells you that it's missing a certain little check for it. When you have to check that. Well, yeah, this is the first missing line. Missing 5 lines. And well, yeah, this is like this angle is fused like this one is like 5 meters. So then it's so that if you lost one
Yeah.
might still have a full
Yeah, I know.
You'll just go to whatever. No, but that's allowed. Yeah.
We are going to more or less kind of sort of start to end today's event. I hope you all learned something, especially like where the difficulties are and what you need to pay attention to and so on. A few final practical things. First of all, in one of the coming days, we will send an email again through the URSI Secretariat with all the slides of the presentations and some other practical things that might be interesting for you if you want to continue learning to scale and becoming a professional or amateur ionogram scaler. So yeah, you can look forward to that in one of the coming days. You are also, of course, welcome to the INAG business meeting if you are interested in ionosons and data coming from ionosons. There is the INAG International Ionoson Network Advisory Group, which is one of the work groups of Commission G of WRC. We have a business meeting on Wednesday. Don't know exactly in which room. Is it this room? In any case, you can see the INAG business meeting in the program. So, and it will tell you there exactly at what time and in what room it is. So, if you are interested in ionogram data, you're welcome to attend this meeting as well. There anything else I need to say? Yeah, we will still be here for most of the week, all the week, maybe not every day, but if you still want to look in the coming days at some of the ionograms to learn a bit more and you have some additional questions, you can of course still find one of us and ask. Ideally, you find only one of us and not two at the same time, because then there will be a lot of discussion and fighting going on. But some of us think that discussing strange ionograms is a fun thing to do. So if you find a strange ionogram, do not hesitate to come discuss it with us. Okay, so that is it more or less for our session now. We will close the session this evening at 7. There is a drink. I thought it was 7, but anyway, it's in the program. You can see it in the program. Okay, so that's it. Unless there is any very urgent, immediate question that you still now want to get an answer from one of us to. No very urgent questions. Okay, then we can consider this tutorial day closed. And see you probably during the rest of the sessions in all the ionoson sessions of the conference. Thank you.